right, so joining me, George Wagner from Liqid.
Thank you. Thanks for having me, Wendell. I appreciate it.
Thanks for getting me hooked up with all of the hardware. We're using my RTX 6000s and my A100s and my MI210s, but we're mixing the streams. You can mix AMD and NVIDIA. I thought that was against the law.
That's right.
We're also using a lot of hardware that's not certified. I'm going to be doing a lot of PCIe experiments in the coming days. But don't take my word for it. Listen to what their customers are doing. This platform, you've already got, what, Ansible and Slurm? And
Ansible, Slurm. We have a VMware plugin, Kubernetes, and yeah, it's growing. List is growing.
If these words sound like some sort of crazy moon language for you and you're watching this because you're working on this kind of stuff in the enterprise, I'm sorry, you're behind the curve. You're gonna have to get caught up on this word salad and see. It doesn't make sense for you to configure individual servers anymore. You're going to have to do it at a software level.
Completely agree. I mean, I was in IT before I got into this side of the business, but for the last 30 years or so or more, we really tied all of our hardware into this notion of a box, right? A box with CPU, RAM, storage, and now we have GPUs, right? Networking, etc., DPUs. And while all of these have gotten exceptionally larger and faster, at the end of the day, you're still kind of confined by what's in the box, what can fit in a box. Yeah. Not only that, but if you're not using it in the box,
yeah,
it's kind of, if it's not being used and it's in the box, it's being wasted. So that's where the notion of this composability comes from.
Well, imagine, go with me on a thought experiment here. Let's suppose you have a VDI infrastructure, virtual desktop infrastructure. Those are GPUs for servers, but they're made for your workforce to log in. Maybe most of your workforce works the 9 to 5. I mean, sure, you have people working late. Sure, you have people working overnight. But what if you could repurpose those GPUs that are usually used for VDI to run inferencing workloads overnight? So maybe it's an 80-20 rule. During the day, 80% of your GPU infrastructure is going to VDI, and 20% is the scientists' inferencing workloads. And then overnight is 20% for those people that work around the clock and your 24/7 staff. But 80% of the GPUs are doing the inferencing workloads. And then 7 a.m. rolls around, boom, you reallocate it. This is all scriptable. You don't have to move hardware around. This is a very reliable, solid workflow that is achievable today.
Yeah, absolutely. We have customers doing it. That use case is actually a multimedia company in California that's doing it. So yeah, they have engineers that work during the day, and 5, 6 o'clock, 7 o'clock when they check out, flip the switch, those become rendering tools.
Yeah.
So
yeah, I'm surprised how much VDI is useful even in architectural firms, and not where you're just trying to pack on as many people as possible. Anywhere where you've got a lot of concerns around intellectual property, which you typically have in engineering and architecture firms, but also increasingly visual effects and specialized industries like that. You can use the composable Liqid fabric to do rendering on what are in the day, your 3D artists' workstations.
Absolutely, yeah. No, we're doing that with a couple as well. Redesign's one, Squeeze Animation in Canada is another one. And yeah, you can create these extremely high performance VDI workstations that you could never jam that much equipment into a single box. Yep. And yet these folks are able to do this type of work remotely.
Yeah. So what we deployed here is a small fabric, but it gives you 8 slots, and we can deploy the host controller in 1U rack servers. In fact, it doesn't even have to be 1U. Our Tyan 4-node cluster that has 4 AMD EPYC Milan systems, completely independent systems in 2U, we can connect all 4 of those nodes to this Liqid fabric. And then even though each one of those is only 1/2 of one rack unit, we can add all 8 GPUs to a single host in that. Or we could do 2 and 2 and 2 and 2, or you could do a larger Liqid fabric and have 8 and 8 and 8 and 8, whatever makes sense. You can mix and match your compute, your storage, and your GPUs. It's kind of mind-blowing when you think about it in those abstract terms.
That's why I joined the company 3 years ago. Yeah, absolutely. So this is a Smart Stack 8 is what you've got in your data center.
Nice. And so if you want to read more about that on the website, it's the Smart Stack 8 on the Liqid website. But you're doing 30 plus GPUs at this point?
We certainly can. Yeah. So we have a Smart Stack 30, which is in fact 30 GPUs. So several enclosures, 30 GPUs, up to 16 hosts. So it's quite capable. And like you said, I mean, you can move those around. So you're getting 100% utilization of those expensive resources. You can have heterogeneous, as you're doing right now, heterogeneous GPUs. You can do NVMe storage, DPUs, what have you, and then use software to simply connect them over the PCIe fabric.
Now, the PCIe fabric is the other part of this that I think flies under a lot of people's radars. And that is that even though it's a PCIe fabric, you can still do peer-to-peer communication. These are fully switched bridges. You're not doing something like the Bitcoin mining where you take 16 lanes and you end up with 16 one-lane devices through janky USB cables. No, this is a fully switched fabric. There's not really much of a bottleneck here. Every host has 16 Gen 4 lanes, up to 32 Gen 4 lanes if you use multiple host bus adapters.
Correct.
If you need that for your host, you can do that, single socket or dual socket, whatever makes sense. But, we'll be pedantic in a little bit. But 16 Gen 4 lanes. But then if you're doing certain machine learning and AI inferencing workloads where the software can communicate from device to device, you can do that. If you have a Bluefield DPU, those support controlling the PCIe bus. And through these bridges, that is a supported use case on the software side of it. If your software stack and your internal programmers, it's not a Liqid thing at that point. That's up to your programmers to come up with that solution. That will work on this fabric, which is also mind-blowing.
Yep. Absolutely. Yeah, no, you can get really creative. And talking to folks like you and I have had these conversations before. We're like, what if we did this? What if we did that? I mean, we're just at the tip of the iceberg here. We're going to really delve into it a lot more in the next couple of years as it starts picking up. You have multiple use cases and problems we're going to be able to solve with this. There's
a lot of these kind of problems that have been solved in the past by OmniPath and more contemporarily InfiniBand. But InfiniBand is not really super available. And so InfiniBand, the great thing about InfiniBand is you can run a lot of things other than networking over InfiniBand. But again, with a PCIe fabric, you are literally using the PCIe bus to do host to host and even inter-host communication. You can build your own PCIe to PCIe tunnels to do extremely high speed, low latency communication. Most people don't realize, but no. PCI Express was originally meant to be a server to server communication protocol.
Exactly. And it's now that you have Gen 4, Gen 5's here, tons and tons of bandwidth. So it's definitely taken advantage of with GPUs and whatnot.
Yep. Very soon, you guys are going to have a Gen 5 product as well.
We will very soon.
But the Gen 4 product is going to be supported for a long time because that Gen 5 product is going to cost.
It's not. Gen 4 is not going away. In fact, we still support Gen 3. CXL is another thing that's coming down the pipe that's getting a ton of fanfare, and we're definitely looking to be front and center in that from a fabric management standpoint. So it's very exciting times.
The infrastructure as code management aspect of this is also very exciting because it makes it possible for architects to build solutions. This is one of the things I'm excited about. It makes it possible for architects to build solutions where they can say, this is what is required for this level of performance if you want to do this. And they could build their solution around a Liqid fabric. Exactly. And then if their product changes or whatever, they already know what hardware the customer has, and they already know everything that's there. And so it's like, oh, you need to move from V4 to V5, just run this. It's like, oh, you need to roll back. Well, just boot off of this virtual machine or boot off of this, and your physical host is configured. It really is handling physical hosts like virtual machines.
Yeah, they're like resources. And when it's time to do an upgrade to your server, you don't have to throw away everything inside your server. It's a pool of resources. So simply pull the host out, put in the host in, reconnect GPUs, reconnect your NVMe, your networking, etc., and you're good to go. Scale up, scale down, all that.
It's virtual machine PCIe device pass-through without you're not necessarily going to have the actual virtual machine component of that. I'm passing through these GPUs in this enclosure to this physical host. It's like, oh, I've changed my mind. Okay, well, reboot the host, and then those GPUs are gone. Now they're going to be somewhere else.
Yeah. Yeah, you can even hot plug. Through the software, we support GPU hot plug. You
can not all GPUs support that.
Yeah, not all GPUs.
I'm looking at you, AMD, reset code 127, header error. You guys got to work on that.
Gonna get me in trouble.
Hey, it's something I've encountered that would be very difficult to support in customer scenarios. I can say that.
Yes.
But you guys, MI210, we're rocking MI210s on the platform, and so far so good.
Absolutely.
Nervous smiles. I'm also rocking a Pensando DPU, which is not officially supported or qualified, but I'm really excited about that as well, because that is a PLX bridge and it shows up as a bunch of different devices, and it is a packet processor. And so I believe that I'm going to be able to expose the P4 packet processing capabilities to a disaggregated PCIe bus and be able to do P4 packet acceleration across a variety of hosts. Pretty sure.
No, that's what I'm excited about. You just hammering away at this stuff.
Yeah, I think that's going to be, we may be able to use this platform to get to the bottom of some of the more enthusiast use cases, because I try to take care of the VFIO community and everything else. And so I'm really hoping that I will be able to use this platform for some off-label level 1 diagnostics of PCIe and everything else. So I can't thank Liqid enough for the opportunity to be able to, because these tools from a debugging standpoint is also hugely valuable, just because if you're going to have your infrastructure like this, and you're going to do infrastructure as code, and you're going to run all these PCIe devices, being able to manipulate the PCIe bus in these ways is very handy.
Yeah, no, absolutely. No, we're excited to be working with you, as always, and excited for what's going to happen. So,
super exciting. Another use case that you might not be thinking of, DevOps. How often is it the case that you have the developer environment and you have the production environment, and something goes wrong when you deploy from dev to production? This can be really pretty easy when you're managing a whole bunch of virtual machines on somebody else's infrastructure. But what happens when you have to manage physical infrastructure? Like, it makes sense to manage VDI hardware. It makes sense to manage this kind of stuff from a hardware standpoint. But what if your DevOps team had a Liqid fabric and your production environment was a Liqid fabric? At that point, there is no difference. You can scale your dev environment as small or as large as you want within the pool of hardware that you have, and you're going to get exactly identical results from production when you deploy the solution to production.
No, absolutely.
I mean, that's huge. That's huge. There's so many companies that get that wrong, and it costs millions of dollars of downtime. Just one little mistake, and the whole thing comes crashing down. And even if you are perfect and something, maybe you have a catastrophic hardware failure, it's like, well, we can use the dev environment as production. There you go. Dev can be dev and staging, and then you have production. But then if something goes catastrophically wrong with production, dev is production. And it's all infrastructure managed with code, but true physical infrastructure.
That's mind blowing. Yeah, that's one of those, like I said, it's one of those things that you talk about that, yeah, it's that kind of opens up, new dimension of how this product can be used. I mean, it's definitely going to make people think differently about, how they can do, create scale infrastructure, better utilize it, et cetera. So,
well, you guys have talked a little bit about Slurm and Kubernetes. Like, what kinds of things, like what sort of customer use cases have you seen with, deploying those kinds of solutions?
Yeah. So the customers that we're talking to today, and customers that are actually using Slurm today, Slurm's a job scheduler. One of the challenges the customers were having, and once again, we talked about this earlier, it's not really a challenge, it's just a reality, right? Reality is you have certain types of servers that were designed with X amount of storage, processing, et cetera, GPUs, and then it'll find those and deploy them. Well, sometimes you have one that has too many resources, one that has too few resources, unutilized, et cetera. So what we're doing is we have a way to, when the job is scheduled, we have almost like a multiverse of options. And, you can take the base server, which is a resource in Liqid Matrix in our software, and you can create the exact server that's needed for a job. And when it's done, it breaks it apart and puts it back into the pool for you. So it's just much more granular, much more efficient, and lets, the researchers create these systems they need at the moment they need it versus having to wait for something. If the resources are there, we can create it for them.
Yeah. That use case is inspiring. I've got my mind's racing with tons of ideas. Like, could we use this same idea to test an entire generation of gaming GPUs? It's not officially supported or anything qualified, but would I be able to add every RDNA 3 GPU in the lineup to the fabric, and then one at a time rotate the GPUs into a physical host and do my testing? There's no bottleneck.
Well, guess what? We have customers who do that. Nice. They've actually purchased it to test hardware that they built. And so they can they can plug in a server to see if they support the server, get a new server in from one vendor, vendor B, vendor A, plug it into the fabric, and cycle through all of the different GPUs or storage devices that are on there versus having to, crack it open, get the screwdriver, cut your hands, pull everything out, put everything in. So it makes it much more efficient, makes our job faster. Time is money.
Yeah, I've noticed that server PCIe slots, some of them do tend to get a little flaky after about 100 insertions.
Right.
And those slots should last a lot longer than 100 insertions, but goodness gracious.
Well, they're not designed for that, right? They're designed, it's like you're supposed to just plug it in and put it away, right? Just shut it, put it away. But yeah, it definitely reduces the amount of time you have to spend digging around, because I used to work in the data center, and I have the scars to prove it early on, so...
Could we build a testing lab that actually captures the output of the GPUs, and then we do frame analysis without actually physically moving the GPUs?
Very interesting. I say yes.
It's going to be a fun off-label experiment, let me tell you.
Yes.
Now, if all of this sounds fantastical and futuristic, that's because it is. But there's a lot of really good documentation on the Liqid website where you can get product information and more information about how it works under the hood. There's also an interactive demo that's going to be out in a couple of weeks from the time this video comes out, maybe like a week, 2 weeks, something like that. And you can use a web GUI, which is actually what you get on the Liqid Fabric controller thingy.
Yep. You get the whole thingy.
Yeah. I mean, I don't know what to call it.
Yeah, we'll call this the test drive, right? So for customers who really want to understand the power of Liqid Matrix of the software and composability and being able to add GPUs, remove GPUs, migrate GPUs between different host servers, this will give them that opportunity.
Yeah, it's literally going to switch PCIe lanes from one device to another device, a physical host, but it's PCIe lane switching. You think network connections and you think other connections to the system is like, if you're on the bleeding edge, you've got 200 gig connections, maybe dual 200 gig, total of 400 gig. PCI Express 16 Gen 4 lanes. We're talking about 8, 16, 32 gigabytes per second in both directions. That's like 320 gigabit. That's madness. And that's in every host with every connection. And if you want to go double HBAs, it's going to be 640 gigabytes. Your main memory bandwidth.
Wait, there's more.
Yeah. Yeah. I mean, it's like, but your main memory bandwidth, you're going to need a Gen 5 platform to push those kind of speeds because it's not going to bottleneck.
No, exactly. Yeah. So, I mean, if like you said, a couple weeks from now, this will be available. It'll be on our website. You go to our homepage. It'll be on the homepage. And you just sign up. You send you a link, you go into a real environment, have access to the real UI, and we'll kind of walk you through the process of, adding a GPU to a host server and maybe a couple of them to a host server in a couple of seconds.
So for the Liqid Fabric we have here in the Level 1 office, this is what it looks like. We have a list of hosts, and we have a list of PCIe devices that are installed on the Fabric. And I literally just click which host and what device I want to be on what host. If I want all the GPUs to be on one host for a little while because I'm doing testing, it's all point and click. Yes, there's an API that I can use to automate this. That's no problem. But it's point and click GUI as well. So if you're just doing R&D and you don't want to have to think about it and you're just like, I need this on this GPU or this GPU on this host, or now I need to move that GPU to this other host. It's point and click. It couldn't be easier.
No, completely.
Now, we were chatting a little bit before the video, and we've looked at really insanely fast storage from Liqid as well. That's another product line that they have, the Honey Badger.
Correct.
So that's a lot of fun. I set up Greg Crow Hartman with one of the Liqid elements, I believe, for storage. As far as I know, he's still using that, and that's great because it's a PLX bridge with a lot of storage behind it. It's compact. It's no frills, but also very, very high performance, and lets you do things that you can't normally do in a desktop computer.
No, absolutely. I mean, it can be used. Actually, you can compose it.
Yeah.
So we talk about GPUs, composing GPUs, because that's the hot topic today. But in order to get the data into the GPU, it needs to be somewhere, right? It's from the storage, so you can put those directly into the enclosures and do basically move it directly into the GPU, bypass the CPU altogether. So it's high capacity, high performance, very low latency.
I want to run my storage off of iSCSI. It's like, how about just native PCIe, because that's about 1 million times more bandwidth. I mean,
Yes.
Even if you've got the highest end infrastructure in your data center, PCIe, it's going to be better in terms of latency. And if you want IOPS, latency is where it's at.
Right.
So how can PCIe not win? Again, this is why it blows my mind that there's not more venture capitalists and not more companies tuned into the whole composable infrastructure, because you're not like, you're the raw PCIe. How are you going to get faster? The only way to get faster is to literally plug a wire into the CPU, bypassing the motherboard. Like, how do people not see that?
That's next.
Intel tried that. It didn't work out for them.
Yeah.
But we're not quite there yet. Yeah. But it's like, oh, we're going to have an add-in card that does, no, an add-in card, that's not fabulous. But the Honey Badger gives you density and gives you performance. I mean, it's 8 M.2, and you can compose them individually. You could just, you can throw one or more in your storage infrastructure, and then it's like, I need this kind of performance for all of the machines in my little fabric cluster thing, and it is access to the raw storage. That's going to work a little differently than iSCSI or NFS or anything, because it's the raw device. Obviously you're not going to be able to access the raw device from 2 hosts at once, but how cool is that?
No, absolutely. Yeah, you can. It's very high capacity, and then, like you said, you can separate those into multiple smaller sections. You can rate them. You can plug in and use hardware rate, software rating, any of that to make it work, and it's fantastic for rendering databases. You name it.
Nice. Storage, more storage.
It never goes away.
Storage fabric
Just keeps growing.
Yeah. Well, that's just how it goes. I mean, if you wanted to compose all of your storage into one host that then does the RAID and software, everything else, and then exposes that again via iSCSI, you could do that. That's an option. That's what happens when you get composable infrastructure.
That's right.
You can make it whatever you want. It's the Zombocom of infrastructure. So with composability and infrastructure and explaining this wonderful magical thing, that can be a challenge.
It can.
And you've experienced a lot more of that challenge. So I'm going to shut up so you can talk.
Thanks. Yeah. So, at the end of the day, you can call it whatever you want, right? Composable disaggregated infrastructure is quite a mouthful, and I have a hard time even articulating it half the time. But at the end of the day, it's just delivering resources on demand, GPU on demand, soon to be CXL on demand via software. So it's all about just, even in the storage days. I was with Left Hand Networks and other companies where we get and talk to customers. Hey, we're going to create these big pools of resources. We're going to give you access to them. We're basically creating pools of resources that including storage, GPUs, DPUs, and CXL in the future. So it's that you can call it whatever you want, but at the end of the day, it's just on-demand infrastructure via software.
You're reconfiguring hardware without physically moving hardware.
Yeah.
And without introducing an unnecessary bottleneck or lots of extra crazy overhead.
Correct.
And it is so hard to explain that to a customer because they don't know to look for that even. And that's what I love about this thing, is because when you understand it, it's like, oh, obviously this is the future.
I know.
But until you actually understand it, until you actually ask those questions, until you bring those things up, it's just like...
I was in an interview once, and the interviewer asked me, how would you explain this to your mom? I kind of got that panic look in my eyes. Well, I would say, Mom, Mom has a laptop, opens her laptop, Mom runs out of storage in her laptop. Mom, imagine if you just hit a button and and it extends it inside of your laptop, right? It wanted to be faster. I hit a button and your laptop's instantly faster. That's really what's going on here. Without having to actually touch it, open it up, anything like that.
Yeah.
I think she'd understand that. I hope she would.
I was explaining this to somebody once, and they were like, well, I don't want to just add more CPUs to the VM. What we do doesn't run well in a VM. Mm-hmm. It's like, you don't have to use a VM.
Right.
This runs on bare metal hardware. It's like, I want all 80 cores of whatever. I want all 256 cores of this monster beast machine. It's like, there's no hypervisor. It can be bare metal if you want it to be. If you use a virtual machine, some convenient things happen for you. Like hot plug becomes a lot easier all of a sudden.
Right.
But if you don't want to do that for your application, this works just as well on bare metal.
Well, so let's say you need 8 GPUs and some 64 core server, whatever you have, and all of a sudden you need another 8 GPUs. The way traditionally you think about it is, I need another server with another CPU and more GPU. Well, is the CPU your bottleneck? No. Then why the heck are you buying another CPU? Why don't you just add more GPUs to your system? That's just, it's just kind of getting around that that conventional thinking that you can do it.
Yeah.
You can add 8, you can do 16, and then when you're done, you move them somewhere else.
Well, right now on the user forum, on the level 1 forum, people that are doing like homebrew AI, the 3090 is hotter right now than the 4090 because people are buying two 3090s, bridging them together, and then you have 48 gigs of VRAM. And that's because the cards can communicate with one another. Great thing about the Liqid fabric is that you've got that peer-to-peer PCIe communication. So in your example, where you've got 2 physical servers, it's like you can't, there's no way to make that work.
Right.
But if all of those GPUs run a single fabric, then you can do it so that you've got one pool of VRAM. And there's no more latency penalty with that than doing it any other way, because it's the true full fat PCIe bandwidth. Those GPUs are connected to the fabric at 16 lanes.
Right. Even between enclosures, right? I mean, it's that one big fat fabric.
Yeah. And there's no interface overhead. There's no protocol changes. There's no, oh, we're running at 200 gigabit today because that's really fast.
Right.
You can't, I mean, not to knock on InfiniBand. InfiniBand is great, but you can't buy it. It's not in stock. It doesn't, and this is PCIe. We don't even have to change the interconnect. And this works for 1 rack, 2 or 3 racks if they're really close together.
Right.
You can do it. You can get it done.
Yep. Yeah, like you said, it's PCI. It's not some newfangled architecture. We're not building anything that's proprietary in nature. It's just PCIe.
Yeah. Sometimes you find bugs in PCIe. Looking at you, reset header 127. I will get that bug fixed soon. Another device that can be composed onto the fabric, FPGAs. Field programmable gate arrays are becoming even more huge. AMD's going all in on their FPGA wafer allocation. So
yeah,
what are customers doing with FPGAs today?
Well, you see, I think we're seeing a lot of customers use them for, obviously more custom type work. Where FPGAs for a while they were kind of boring. No one really used them as much. Now you're seeing with GPUs. GPUs are used for AI, ML, inferencing, etc. We're starting to see customers program them to do be more purpose built for a particular part of that AI workflow. So, inferencing, training, etc. So it's like you said, I think Xilinx, everyone else, it's definitely getting more into we're starting to see a lot more traction with that with our customers than before.
So with an FPGA, a lot of the time the bus workload from like the PCIe perspective is the FPGA is going to slurp up a lot of data, and then it's going to cough up a very small amount of data. Whether that's AI or even video workloads, there's a guy on our forum that does a very large video distribution CDN, and one of their things that they were looking at for fabrics was, I really need like 20 slots for FPGAs because the CPU is not doing anything. I just need to copy data from the network and from everywhere else, and then send it to the FPGA, and then get a bunch of streams, and that's all they need.
Yeah, yeah. I mean, like you say, it's just like clay, right? You mold it into whatever you need. And like I said, we've probably seen an uptick in interest in composing FPGAs probably in the last year and a half. While they've been on our HCL for years, we're definitely starting to see an uptick in interest in that as well.
A lot of customers are looking at using that as a stopgap for custom silicon too, I imagine. Just because it's like, I need wafer allocation. Oh, sweet summer child.
Yeah, and in the director, you can actually, where we store our software, you can actually put different personalities on there and load them. We can load them for you right inside Matrix. So
nice.
Yeah,
well, that's a level of support that you don't have to worry about that in your initialization script.
Nope, exactly.
Yeah, nice. It's like if this is all sounding like something overly complicated, it's actually a vicious, bloodthirsty, cutthroat simplification. It's like, oh, we've got a server and it's got all this fast stuff. We're going to put this special interface in it that can handle all of this stuff. Nah, Liqid, it's PCI Express. That's the connection.
Yeah.
There's no latency overhead. There's no protocol changes. There's no anything. It's just PCI Express. Now, PCI Express wasn't meant to scale to data center levels, but for managing things a rack at a time, especially with composability, it starts to make a lot more sense.
No, I completely agree.
Well, this has been amazing. There's going to be a lot of videos on this platform. I'm going to have a ball with it. If you work on an open source project and you want access to this, definitely hit me up. If you've got some off-label uses and you're thinking about spending a few $1 million with Liqid, definitely hit them up. But let me know if I can help, or check out their case studies and use cases, their hardware compatibility list, which they do publish because there's all kinds of stuff on that. So check out all that. And George, thank you.
Thank you.
Thank you. This is going to be amazing. I can't wait. This is so exciting. All right. Catch you later.